All right, so we're going to pick up volumes of revolution here, kind of where we left off. And we're going to look at a couple different ways of spinning some figures, creating some 3D shapes. So if we look at our function again, y equals square root of x, we were examining this curve from 0 to 4, and we were going to then take the 2D area that we see here, and we were going to spin that 360 degrees around the x-axis, creating a solid. The equation to find that volume is the integral from a to b of pi times y squared dx. It's a little bit funny. We usually, when we see the variable y, we would see it followed by dy. But in this case, y stands for the radius of our solid. It might be this length or that length, and it's given to us in terms of x, because y is equal to the square root of x. So if we were going to actually calculate this, it would be from the lower bound of 0 to the upper bound of 4. I would actually bring the pi out in front probably. That way we can just leave what y is in terms of x, that's the square root of x squared dx. And if we integrated, we would have the volume of our solid. So we're going to put a little bit of a different spin on this now. And we're going to, let's get this synced up here. We're going to spin this curve around the y-axis this time. So where are we going to go? Before we chose from 0 to 4, I'd like to choose this same point, same point there. And so that happens really at a y value of 2. So why don't we look at taking this area, heading between the curve and the y-axis, and let's spin that around our y-axis. Okay, so how does the equation change? Well, our volume equation, that is if we're going to be spinning around the y-axis, is going to be similarly from a to b, the lower to upper bounds, pi times x squared dy. A good indicator on these are what variable you should be using is that if you see dy at the end, then we know that our radius should be expressed in terms of y. So in this case then, where we see y equals the square root of x as our function, we'd really want to say, well, what does x equal then? And in this case, x would equal y squared. If we squared both sides, we would create the equation x equals y squared. So then, to calculate the volume of our shaded region in this new problem, spun around the y-axis, it would be pi from 0 to 2, our y value bounds, of y squared squared dy. And that would obviously give us a completely different shape. It would give us, kind of like a Hershey Kiss shape, I guess, where it's like kind of tapers to a point on both sides. You know, something like that, spun around the axis, okay? And now we're going to look at another unique situation of revolving areas around an axis. We're going to go back to revolving around the x-axis in this example. Now, the thing about this is we're really going to revolve just the shaded region, which is going to cancel out, it's going to cancel out the rest of this unshaded region from the outer curve. Okay, it's kind of like subtracting away. It's taking an outer volume and subtracting away an inner volume. So really what we would do to calculate that volume would be to take the integral from 0 to 1 of the outer curve, and the further away curve is really y equals x, the top curve, squared dx. Oops, where's my pi? There it is. Pi times radius squared. Okay, x is our radius. And then we're going to subtract from that, from 0 to 1, pi times the inside curve, x cubed squared dx. Okay, and we could really express this a little more simply if we, well, first off, we could factor out that pi, do just one integral from 0 to 1 of x squared minus x cubed squared, and do all of that with respect to x. And what we really see here is we have the outer radius of our figure squared minus the inner radius of that square. Okay? And we're going to not take shortcuts here and not try and subtract them together, okay? Because as we would see, so this is what not to do, is if we were to do volume being equal to pi times the integral of 0 to 1 of x minus x cubed squared, we would have to square this binomial okay, and that is not going to be equal to x squared minus x to the 6th. All right, so just be careful not to try and do that all too quick. Keep those problems kind of separate, and then and really just subtract one from the next, and you should do just fine.